Okay, so here we go. All right, I'm going to share my screen so that you can see. This is your class. And if you go to the welcome message, which right here, this is the one that they wanted us to post. So I want you to see, it says, okay, classes will be held virtually January 10th through 22nd. You will log in during the regular scheduled class time using this meeting ID. See, I put it on there too. The attendance will be taken each day the class meets. You're required to turn on your camera and be engaged during class. Today, we're going to not do the camera thing because, you know, we're just talking about the class itself. But when we are actually having a lecture, we are all going to have our cameras on. Then it says after January 22nd, the college has chosen the hybrid format. So you'll have both. And on Tuesdays, I'll be on campus. And on Thursdays, we'll do it this way, okay? And if you have a Friday class, all classes are on off campus or online during Fridays, every Friday. But this class doesn't do that. So when we do see each other, everyone's supposed to wear a mask, including me, obviously, while you're in the building. If you have any questions, you can contact me here, or you can just use the messenger, which goes directly to my email anyway. And okay, so let me keep going with this. Okay, so that's one. Let me see what else we got here. I haven't yet put up my class schedule or anything. And don't worry about this final exam. That's just I always have two, so I choose one or the other when I do my final. So I just always keep the other one hid. All right, so I have a lot of welcomes on here, but never mind with this one because this is not supposed to be showing. See, when I put this in, it was actually, I'm supposed to just delete that. Yeah, remove it. Okay, I'll remove it later, but basically this is your suggested schedule for this class. I know it says 133. I imported and I forgot to change some of the things, but not everything. All right, so this is your first thing you're going to do. You're going to do an introduction form. You're going to introduce yourself and reply to two other people. And with it, you're going to, this is the introductions page. Here where you go to the actual introduction area. All right, so basically you just need to say something like what your major is, what your aspirations are, what your hobbies, you know, where you're from, if you want to share that, whatever it is that you want to share. All right. And there will be a discussion forum for every topic. And there's my office hours, which I have not yet decided on because I still have to hear from my other school, whether we're doing online or not. And if we're doing online, that's a different story than if we're doing in person. So I have to, you know, make sure that I know that first. All right. So I usually do a remind, but I don't know if I'm going to do that. Okay, so here's where we're going to start. We're going to actually start with Vesper. This is our first thing. Vesper and polarity, intermolecular forces. I know you've seen these, but this is a review because we need to know this. And then you will have a test on it. And we will do formula calculations where we are going to also do, this is out of order. Yeah. Anyway, yeah, see, that's supposed to be above that. So I'll fix it all. But empirical and molecular formula calculations will be our first thing that we'll do, actually, this right here. And from there, we'll review and we'll take that test. but this is your first one. So when you look at discussions, we already have a few. I haven't yet, and this is our first one. So I gotta once again move them around. This is our first one here, and I'm gonna change all these numbers. It's just all backwards. This one should be first, then this one, and then this one. Yeah, they're all, the top and the bottom are mixed up. And I will be adding discussions as we go. Now, let me show you our first discussion. Basically, it says answer both parts of the following question and contribute to the discussion by posting 4 additional substantive posts in response to someone else's post. Using a compound's molecular or empirical formula, come up with a question related to its molecular or empirical formula. Answer the question using a step-by-step approach to figuring out the formula. So here's an example. A compound contains 85.6% carbon and 14.4% hydrogen. What is its molecular formula if the molar mass of the molecular formula is 28.06? Okay, so step 1 is to convert the percentages. Step 2, do that. Step 3, do that. Step 4, do that. So this is my example to you. Step 5, and there it is. And now, what is considered a substantive contribution? Okay, so your contribution would be something like, don't say, oh, great answer. I like your answer. Oh, I really appreciate you doing this. I understand it so much better now. No. Substantive means you need to know. For example, you could say, what would the answer be if the molar mass was equal to this, or something like that. But of course, you've got to make sure that you know your molar mass or whatever. So basically, or you could ask, is it possible for a compound to have an empirical and molecular formula that are the same? And the answer is yes. It just depends, But so something like that. And then you have to first respond to this before you can see other people's responses. Then once you do that, then you will do another 4 responses, and they will be in addition to the ones that I'm adding. Now, there should be a source of information, and if it's your textbook, then put your textbook. Doesn't matter, just as long as you have, or if it's an internet, it's a problem on the internet, use that. But you're going to have to solve it somehow. Remember that. Okay, so this is how it works. This is the main thing, is that you are actually discussing with each other, because it's important to get other people's opinions and other people's approaches to things. Something might resonate better with you than what I'm doing, so just remember that. Okay, so let me go back to home, and each topic will have one. And like I said, this was just something that I had to bring it all in quickly because of them saying that we were going online. So, all right, as far as that goes, this is new. This part that we're first learning is new. This empirical and molecular formula is brand new. Stoichiometry is not. Types of chemical reaction is not new, but the products, how to predict a product, is new. Then you got your solubility rules and your solubility chart. And the activity series, all of that. Redox reactions is not new. Is new. Energy, all of these are new. Everything from here on down is new. See that? Every single thing. Before that, we are reviewing a few things because they're important for you to know before you can actually do the rest. So we are reviewing chapters 3 to 7, basically. So remember that 3 to 7 is review, and then we start with chapter 9 and go on all the way to chapter 21, not including 18 and 19. Okay. So that's what we're going to be doing this semester. Now, as far as the lab goes, oops, sorry, let me go back home. The lab goes, we have Labster again, and these are already ready here. Of course, you can't see them yet because I haven't published them, but I will. First thing that you'll be doing is lab safety. Then you'll do properties of water, reaction kinetics, ideal gas law, equilibrium, calorimetry, recrystallization, simple distillation, acids and bases, carbon valence, organic chemistry introduction, and this is part of biochemistry. So you'll have all of this. Now, I did not put anything on nuclear chemistry here because I am not sure if we'll get to it or not. If we do get to it, it won't be part of the test anyway. So if we do get to it, it'll just be an extra thing that I'll mention. But I'm thinking we're not, based on what we're reviewing, plus all the other stuff you guys got to do. So there will be a final lab report, which is not on here yet, but the final lab report will count for 20% of your grade. And oops, sorry. You are supposed to keep, let me see here. Somewhere in here it'll say, let me go back to, there are no discussions on lab, obviously. They're just assignments, but there is something that I put on the home. I don't see it on here. I always put something on here. Maybe it's under announcements about you having to keep, yeah, there it is. Okay, so I did do it that way. Okay, so it says all simulations will be done through Labster. You are required to keep a lab notebook. The reason you're required to keep a lab notebook, just as if you were in a regular lab, is so that when you are writing your lab report, you can just choose which one and you'll have all the information right there. Now you have to show me the one that you plan on using, because some of these are not so conducive to it, to actually writing a formal lab report. And I will determine whether that is a proper one or not. If you say, let's say, for example, lab safety, no, that is definitely not one, you know. But for example, something like reaction, ideal gas law, equilibrium. Equilibrium is probably a good one for you to look at. Calorimetry, that's going to have a measurement. This one too is going to have a measurement. So anything that has an actual measurement, like see acids and bases, acidity and alkalinity in everyday substances, that might be an okay one, but it won't have any actual experiment. None of these will probably have any actual experiments. So there's some that you can't use, some that you can. All right, so let's go back to the class. On here, this is your textbook right here. So if you just click on that, it'll take you directly to, you see that? The textbook. And that's what I was telling you. And if you click on table of contents, I told you chapters 3 through, so 3, see there's formula mass and mole. So all of this right here, chapter 3 is what we're starting with. And then we've got chapter 4 and 5. 5 is new, actually. And 6, yeah, 6 through 7. And yeah, the molecular bonding. So, and then actually 8 also. So 3, but 8 is actually new. So that's why I said it's 3 to 7. And then I said we started in chapter 9, but it's actually 8. Because you do want to look at the advanced techniques in molecular bonding. Right, so all of this is going to be what we'll cover. And like I said, not 18 or 19. We're not going to look at those right now. And then we're going to probably not get to nuclear chemistry because we are adding biochemistry, which I think it's important since a lot of you are biology majors. You definitely want to put that connection together. Right, as far as that goes, if there's any glitches, and this is a brand new course that I just created, so if there's any glitches, see like right here, the assignments aren't assignments, so you cannot look at those. You gotta look at modules, okay? Yeah, they're not in the right spots. So, but you will know which one is an assignment by this sign right here. See, like this is a quiz. You see that? You got a syllabus quiz, but I'm not actually doing the syllabus quiz, so because I haven't finished my syllabus all the way yet. I'm still working on it. It is one of those things that takes time. All right. But I do have that test in place already, and it is ready. And these are all, see, every one of these, as you can see, they're all practice. Now, as far as the assignments, I'll be posting them on the assignment thing, and they'll be coming from your book, okay? Usually I'll say do all the even, no, all the odds, because the evens have actual answers. So if you went to your book, you can see, let me see here, where's the book? I know it's, there we go. I'm gonna clean this up a little bit better. All right, so your book. Okay, so let's say we are in the middle of empirical and molecular formula, and you wanted to look at some problems. Okay, so I want you to do, see right here where it has exercises. I would say go to that chapter, and I would pick, see, formula, mass, and the mole constant. Okay, so you already know how to do formula mass, also known as molar mass. And well, not really, but could be. All right, all of these, not going to get you to do all of those, that's too many. But molecular empirical formula, no, that you will need to do a few more. So see how 32 is not blue? See, 33 is blue. So that means that you can look at 33 to do 34. You see that? Come on, 33. It's loading. There it goes. See, 33, it shows you the answers. See, percent of nitrogen is this, hydrogen is that, sodium is that, sulfur is that, oxygen and calcium. There it is. So it does give you the answers for all those odd numbers. So I'm going to get you to do even ones only, because that is what you need. We may use some even ones, I mean some odd ones, to do examples so that you can know what to do with them. All right, so as far as that goes, that's where the homework's going to come from, and some of them are going to come from my own stuff too. So let me go back to modules. Oh, that's not the right one. Sorry, wrong one. Again. All right. And we're going to look at modules. Yeah. And so each one of these, hold on, it's time when it rolls. See, all of these are, every one of these are, see, every single one are just objectives and things like that. So nothing here is an assignment. So what you want to do is you want to go to molecular empirical formula. And see, that's a PowerPoint, and it shows you in here how to do it step by step. In addition to me showing you here, we will actually be using this, okay? So we have a lot of materials that I posted for you. Okay, see, no, there is no homework on here that I see. Nope. See, only activities, reading, but the reading basically is, I'm going to be posting that soon to hydrocarbon naming practice. And then we got these all, yeah, these are extras that I don't need. Okay. So biochemistry is where we stop, right? And then it says the end. When you see the end, don't look at anything else because there's nothing else there. Organic chemistry, acids and bases, gas laws. So all of this and is what we'll be looking at. As far as if I look at the student view of this, which is what you would see, I see less than I do. Of course, because I have my own workings. So see, all yours is cleaner. See. Okay. And don't worry about the virtual. And this needs to go away because we do not have a third-party course. We do not use anything. And let's see. Yeah. This is some videos on here that you will be watching. Yep. Redox. Yep. Gas laws. Gas laws is, well, there's a lot of stuff on gas laws. Okay, yeah, so that's it. It doesn't look like a lot, but one of the things I will tell you, if you know, as not as not math intensive as the other ones were, this is very math intensive. There's a lot of problems on here. Every single thing that we do is going to require formulas that you can have a cheat sheet. I don't care. I mean, the formulas, as long as you know what they mean and how to apply them, that's what I care about more than anything. And how to find out the answers by having those formulas. That's all you really need. So pretty much that's what I wanted to share with you today. If you have any questions whatsoever, please go ahead and ask them. No? No questions? Okay. All righty, so there are deadlines already set. I don't know if you've seen those, starting with your first discussion, which you are just going to do, you know, an introduction, because I want to know about you too. You are my students and I need to know what your majors are and all of that. And your future plans. Maybe I can help you. Oh, the other thing, I don't know if Dr. Gorski mentioned it, but we are doing an ACS chapter at Wiley, and a student chapter, which means that you guys can join the American Chemical Society. There are a lot of things, a lot of activities that happen through them, including several like seminars and talks and dinners and things like that that are interesting. So you might want to look into that. Dr. Gorski has all the information because I'm not on campus, so, but she does. She has it all, and you can email her or whatever, and she has all the information for you. If you have any interest, like I said, just email her and she'll respond right back. And pretty much this is all we needed to meet for today. I'm not gonna make it a long class, but next time, which means Thursday, we will start. Okay. Now, as far as the lab goes, you know, I did not check to see if the lab was open already. I think I did, but I could swear I set them, but let me check because I have them set so that each one is due at a certain time. You guys check yet? Let me see. Oh Lord, I did not check on that. Okay, so if I click on life safety, it's going to load for me, but the main thing that I need, I see how I'll just show you what it looks like. If for some of you, you've already pretty much familiar with Moodle, I mean with Labster, but this is how it looks. It's like sort of reminds you of a video game, an interactive video game. Now, with this one, it takes a while to load because the graphics are pretty good. So it takes some bandwidth, and you have to make sure that you have all of that. The help center is right here and all of that, and you just make sure that you've got it, okay? I am staying on the tab until it finishes loading. It takes time, like I said, but then all of a sudden it just loads pretty much all at once. And if you get off the tab, it will stop loading. I tested it, it's true. Sometimes they tell you that so you don't go away, but in this case.
Welcome to the lab safety simulation. I am Dr. One, your AI lab assistant. Today, you will learn everything you need to know to survive your first day in the lab. Are you ready for the challenge? This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click Continue to learn how to navigate through your mission. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you've played a Labster simulation?
Well, if it is up to you which one you choose. Since I'm already familiar, I'm going to say no.
Perfect. But then let's get started with your first mission. First, find a lab coat. Click on it to put it on.
Okay, you see how it puts the arrows? And all you have to do is scroll down and you'll find the lab coat. Then these three little arrows, these three little arrows will appear and you click on those.
Now pick up the safety goggles and you are ready to go.
I'm getting the safety goggles from my computer saying it's slow, so I have to plug in. All right, here we go. All right, so right down here, see how it's showing me where to go? So it's pointing to, oops, see, I passed it. It's like, oh, there they are, see? Boom. Okay.
Click on the door to enter the laboratory.
See, it's showing me where to go again. And there it is. I'll just click on that. Boom.
This lab was used by first-year chemistry students, and they obviously didn't leave it in the safest condition. Have a look around and identify the different hazards. Find 5 safety hazards and click on them.
Okay, so it's pretty much, look at this. I mean, You do not want to block a door.
Well spotted. Every lab has 2 emergency exits which ensure that nobody gets cornered in the event of a fire. The emergency door isn't any good if it is blocked by objects. Click on the handcart to move it to a safe location.
So we need
Well done. The emergency exits have to always be clear. 1 hazard down, 4 more to go. Identify the hazards by clicking on them.
let's see here. Well, here's one. This is not closed.
The fume hood constantly draws air through a filter to ensure that you don't get in contact with dangerous chemicals. The airflow only works effectively if the glass sash is pulled down. Let's close this fume hood.
There we go.
What a relief. Now the air is safe to breathe. There are 3 more hazards.
Okay.
Can you find them?
Well, this should never be like this. It's all messy.
A sink full of dirty glassware isn't a nice surprise. Make sure you always clean, dry, and put away the equipment after every experiment. Let's remove the glassware. Beautiful, clean and tidy. There are 2 more hazards. Can you find them?
Yes, this is messy. Should never leave anything
That's
messy.
it. This bench looks very messy. It is important to keep the lab bench tidy. Any clutter should be cleared away before starting a new experiment, and there should be no hazardous chemicals left on a workbench. There is 1 more hazard. Click on it.
And this. Can you imagine tripping on this?
For sure, chemicals need to be stored in designated cupboards and not just placed on the floor. This is especially important for reactive chemicals. Flammable liquids need to be stored in fireproof cabinets.
So far, we haven't
Time
earned
to
any
take
points.
care of the
That's why I'm
hazardous
still
chemicals on
going.
boxes. Click on them to have a closer look. Click on the bottle containing flammable liquid. Check the media tab for help. Well done. The red diamonds on the bottles are called hazard symbols. Each of them depicts a different hazard. Have a look at the following overview of the different hazard symbols.
So if you didn't know, then you would have clicked on this and it would have told you. See? So look at them closely because they're all over. Got it? All right. Now,
Which symbol depicts an oxidizing reagent?
that'd be D.
Precisely. Oxidizing reagents are very dangerous because they can accelerate chemical reactions, such as fires,
See, we're
by providing
earning score
electronegative
now.
atoms.
You see, because we're answering questions. So far, we hadn't done anything
What does the following
necessarily.
symbol mean?
What do you think? Health hazard? Harmful? Well, let's find out. If you don't remember, you can always check it. See, look. So it is a health hazard. See, right there. Okay, so back. Go back to home and answer. Health hazard.
You got it. There are many kinds of health hazards. Substances with this symbol can cause respiratory problems, induce mutations and cancer, or may be toxic to specific organs. Here is an image of the hazard symbol on the
That's
box.
very obviously
What does it mean?
explosive.
Well done. These chemicals definitely don't belong here. Imagine if somebody walks into the pile and the glass bottles fall onto the floor. If they break, they could light a fire and the explosives next to them would certainly produce a bombastic news story. Before you touch anything else, you better put on some gloves. Click on the glove box to put some on.
Guess we didn't have some, we just had goggles.
Click on the bottles to remove them. Let's get rid of this safety hazard. Click on the cluttered workbench to tidy it up. Oh dear, this workbench is a real mess. Hopefully, you will never see something like this in a real lab.
It is a mess.
Let's take care of the problems one by one.
Let's
Start
do
with
it.
turning off the Bunsen burner. It is very dangerous to keep an open flame unattended.
Yes.
Turn off the Bunsen burner flame. Great. Now click on an object that you should never bring into the lab. Well spotted. Food and drink are strictly prohibited in the lab. Imagine if somebody grabbed the wrong bottle by mistake and took a sip of the toxic substance. There's another object that doesn't belong here. Find it. Exactly. Personal equipment is not supposed to be placed on workbench surfaces. Could you imagine what would happen if this backpack caught fire?
Mhm.
There is a living organism on this bench.
Mm.
Can you find it?
Yes, petri dish.
Oh, have a look at this. There is a bacteria colony growing on this agar plate. This might be some dangerous pathogen. We need to use a special bin for biological waste. Discard the petri dish with the unknown bacterial sample in the biohazard. There is still a protocol from a previous experiment on the table. Clean up the lab protocol.
Ooh.
Oops, you just spilled a hazardous chemical. Have a look at the hazard symbol on the beaker. What does the hazard symbol on the beaker mean?
Can't see it. Thing is, it's corrosive.
Brilliant. This is a corrosive chemical. We are dealing with either an acid or a base. You can use a pH indicator to figure out what it is. You only need a tiny drop of the indicator. You can use a micropipette for this. Pick up the pipette from it. Now pick up a pipette tip from the box. Draw up a drop of the indicator liquid. Now add a drop to the spill to identify if it's an acid. Fantastic. When you added the indicator liquid to the spill, the drop turned red. This means the spilled chemical must be a strong acid. We need to neutralize it before cleaning it up. Strong acids react with your skin, can cause burns. That's why it's very important to protect your hands with gloves. Spills of strong acids or bases have to be neutralized before you can dispose of them. Sodium bicarbonate is the chemical term for baking soda. It neutralizes the acid, and the remains can be scooped into a plastic bin and discarded. Let's neutralize this acid spill. Pick up the baking soda. Put baking soda on the spilled solution. Well done. Now put the neutralizer back on the shelf. Now it is safe to use absorbent paper to clean up the spill. The neutralized acid can be disposed of in the solid chemical waste. Usually, the chemical waste is stored in a fume hood. During the cleanup, your gloves got contaminated. You need to dispose of them to avoid spreading chemicals over everything you touch. Click on the trash bin to discard your contaminated gloves. Why didn't you just clean the spill with water?
What do you think? What would you say? A, B, C, or D? Which one? So anyway, but that's kind of how you do this. You go through and you answer all the questions, and if you don't know, you read. If you don't know, you read, like right here, media or theory. If you don't know, there it is, right there. It tells you. You would react, blah, blah, blah. Violent. Okay, so chances are that you would say that would be
superb. If you drop water into a strong acid, they react and produce a lot of heat.
See?
The reaction could potentially lead to splashes of acid. A drop of such a corrosive chemical in your eye could cause serious damage and lead to blindness. That's why it's essential to wear safety goggles all the time.
Okay, anyway, so that's how you do this. I'm
Now,
not going to
just
go
because
through the
this is
whole
a virtual
thing, but
lab, let's do something crazy and simulate a situation in which you don't wear any safety goggles.
let's not.
Don't try this at home. Put the goggles on the bench.
Escape. No. Okay, but so you see how that works. It's a pretty cool little program, and it goes through every lab, everything that you have to do, it tells you. So pretty self-explanatory. You earn points as you do it, and you can redo it, by the way. If you don't like your score, you can always redo it. Or if something happens and your Wi-Fi cuts out and it turns it in or whatever, just keep on, you can go back. So it's not it's like in a lab. I mean, if you need to go somewhere, you stop it and you keep going next time at a stopping point normally, because you cannot just stop anywhere, but that's how it works. So the things are already in place for you to just click on and go forth from there. And as far as that goes, that's it. That's all of the lab and lecture components that you need. Like I said, I will be posting my office hours once I know exactly what the other school's going to be like. But in the meantime, you can always just email me. And we don't start classes over there until the 26th, I think, but they haven't determined if we are going online or not yet. So I don't know. But up until then, I am pretty much free. So if you need me, like if you get stuck, not today, obviously, but once we get started next class period, then you can just email me. I'm pretty good at answering. All right. Okay. You all have a great rest of your Tuesday, and I will see you Thursday. Bye, guys. There we go.